Parenteral nutrition refers to feeding that occurs outside the intestinal tract. Gastric feeding tubes or nasogastric tubes are not examples of parenteral nutrition because these methods still involve the delivery of nutrients to the intestinal tract. The two bags on the left show how in parenteral nutrition, nutrients are delivered directly to the circulatory system, either through a peripheral line or through a central line. The term PPN refers to partial parenteral nutrition, and TPN refers to total parenteral nutrition, where a PPN supplies partial nutritional requirements and a TPN provides the patient's total nutritional requirements. Parenteral nutrition is used for people who have damage to the gastrointestinal tract or liver, or who have severe malnutrition, or a critical illness that prevents enteral delivery of food. When delivered peripherally, it's better for parenteral formulations to be close to isotonic to prevent venous damage. Parenteral calculations may involve determining the amounts of macronutrients, micronutrients, water, or drugs to include in the feeding formulation. Macronutrients refer to carbohydrates, proteins, and fats. Micronutrients include electrolytes, vitamins, and trace elements. You will need to memorize the number of dietary calories delivered parenterally in each gram of macronutrients, as shown on this slide. These values may differ slightly from enteral values and may also vary between formulations, depending on whether the nutrient formulation contains other ingredients that contribute to the overall calorie count of the product. It's important to note that dietary calories, which are often denoted with a capital C, are the same as the energetic unit, kilocalorie. Don't make the mistake of assuming a dietary calorie is the same as the base unit calorie, otherwise your calculations will be off by a factor of 1,000. You also need to memorize the daily protein requirement for an unstressed adult. This is a weight-based value where 0.8 grams of protein is required per kilogram of body weight per day. The first example problem deals with a micronutrient, magnesium sulfate. It asks how many milliliters of 10% weight volume magnesium sulfate with a molecular weight of 120 solution should be used to compound a 2-liter TPN order that contains 10 milliequivalents per liter of magnesium. The first thing we do is calculate the equivalents per mole for magnesium sulfate. We know that the charge on magnesium is +2, on sulfate it's -2, and so we crisscross to get Mg2 sulfate 2, which can be reduced. Both of these numbers can be divided by 2 to give Mg sulfate. So the equivalents per mole are the subscript times the superscript. We could pick either one to do that with. And so 1 times 2 is 2 equivalents per mole. And that's the conversion factor we'll use in our calculations. So if the order contains 10 milliequivalents per liter, how many milliequivalents are in 2 liters? So we have a 2-liter TPN. We need to scale it up from 1 liter to 2. After cross-multiplying, we see that we have 20 milliequivalents in the TPN. Next, we can use our equivalents per mole conversion factor to see how many millimoles is represented by 20 milliequivalents. So if there's 2 milliequivalents per millimole, how many millimoles in 20 milliequivalents? And we see that we had 10 millimoles of the salt. Next, we can use the molecular weight to determine how many milligrams. So 120 milligrams per millimole is the molecular weight. We have 10 millimoles. So 1,200 milligrams. We can convert that to grams by dividing by 1,000. And then we want to know how many mils of the 10% solution should be used. So we have 10 grams per 100 ml in the 10% solution. How many mils of the solution would give 1.2 grams? And we have the answer 12. In the next example, you're asked to calculate how many total calories are in a 1 liter TPN solution that has 24% dextrose, 12% proteins, and 6% fats. We start out by noting that 1 liter is 1,000 milliliters, because we'll use that throughout all of the calculations. And then we'll go macronutrient by macronutrient to determine the number of calories each contributes to the total. So for dextrose, we have a concentration of 24 grams per 100 milliliters. We ask how many grams of dextrose are in 1,000 milliliters. And so we cross multiply and find there's 240 grams of dextrose in the solution at a ratio of 1 gram to 3.4 kcalories. We can calculate the total kcal contribution of 240 grams dextrose. And so that works out to be 816 kcals. And we can do the same for protein. It has a concentration of 12%, so 12 grams. And we can calculate how many grams of protein is in there by cross multiplying. And so in 1 liter, there's 120 grams at a rate of 4 kcals per 1 gram of protein. We have 480 kcals for 120 grams of protein. And then for fat, we do the same thing. There's 6% fat in the TPN. So in 1 liter, that's 60 grams of fat at 1 gram per 9 kcals. We cross multiply and see there's 540 kcals. So 800 plus 480 plus 540 equals the total number of kcals in the TPN, which is 1836, and we remember that kcals is the same as dietary calories. All right, so take a look at the problems for you to try, and we'll work them out in the next video.